Okay, so in today's lesson, we are going to go over polyatomic ions. Now, this is a pretty big word, but we're going to go ahead and break it down, starting with the word ions. Now, we know that ions are anything that has a charge associated with them. They can be positive or negative, they just have to have some form of charge. In addition to that, because we're dealing with ions, that should probably cue you in knowing that we're working with ionic compounds. The reason for that is because ionic compounds are the only ones that involve any ions at all. Obviously, covalent compounds do not work with ions. Then if we move on to the other word, polyatomic, poly means many or more than one. And atomic obviously stands for atoms. So if we break the word down, a polyatomic ion is just an ion that's made up of more than one atom. Every other ion that we've been working with up to this point has been monatomic, so it's only consisting of one atom. So if we look at an example like nitride, nitride has just been a nitrogen with a -3 charge. As you can see, it's monatomic in nature. It's just one nitrogen with a -3 charge. A polyatomic ion looks something like nitrate. If we look at nitrate, it's a nitrogen, 3 oxygens, and the entire ion has a -1 charge. So the combination of your 1 nitrogen, 3 oxygens will give you that -1 charge. Now, your polyatomic ions, they're still ions, so they'll behave just like every other ion. So you're going to pair it up with an oppositely charged ion, and you're going to crisscross those charges in order to make a formula. So if I wanted to make a formula like, let's say, sodium nitrate, this is a pretty simple procedure. We know that sodium is a metal, it's Na, and its charge is +1. I get that just on the periodic table. Nitrate, unlike nitride, is a polyatomic ion, and it's 1 nitrogen, 3 oxygens, and the whole thing has a -1 charge. Now, in order to combine the two together, you crisscross the charges. So the one under Na, on top of Na, goes under NO3, and the one on top of NO3 goes under Na. So that means that we have Na, invisible 1, and then NO3, invisible 1. So I have 1 sodium and 1 nitrate. If you noticed, I did not move the 3 under oxygen. Remember that we only crisscross charges. The 3 under oxygen is not a charge, it is simply a subscript. Okay? Now, there is one little rule that we have to know about polyatomic ions, and that's that whenever you have a subscript being placed under a polyatomic ion, so when you did the crisscross, you put a number under it, you have to enclose that polyatomic ion in a parentheses. So an example of that is magnesium nitrate. If you look at magnesium nitrate, this is the formula for it. MgNO3, and that NO3, the nitrate, is enclosed in a parentheses, and then a 2 is placed under it. What this does is it prevents 2 subscripts from being stacked on top of each other. And in addition to that, it clues you in knowing that this 2 means that you have 2 nitrates, 2 NO3 molecules. Okay. So again, polyatomic ions are just ions that have more than one atom making them up, and they'll behave just like every other ion. The only difference is they're obviously comprised of several more atoms. Now here's a table of several common polyatomic ions. You'll notice that in this table, we've separated out the cations and the anions. And as you can see, there are a lot more anions than cations, with the only cation we're concerned with right now being ammonium, which is 1 nitrogen, 4 hydrogens, and that has a +1 charge. Now, if you look at all of your anions, you'll notice that they all end in either ate or ite, with two exceptions, those being cyanide, which ends in "ide," and hydroxide, which also ends in "ide." But in general, when you see something that ends in "ite" or "ate," that's a pretty decent clue that you're going to end up using a polyatomic ion. Okay. So now we're going to go ahead and use all these polyatomic ions to do some practice problems. So for the top ones, you're going to name each of these, and for the bottom ones, you're going to write down the formula. So go ahead and pause the video and try these out. Okay, that probably should have been enough time. So let's go ahead and get started. Na2SO3. Well, we already know what Na is. That's just simply sodium. And then SO3. If you look back at the table from the previous slide, you'll see that SO3 corresponds with sulfites. If you find sulfite on the table from the previous slide, you'll see that it is SO3 with a -2 charge. That probably clues you in as to where this 2 under sodium came from. CaNO3 Ca is simply calcium. And if you look at the table from the previous slide, you'll know that NO3 is nitrate. This is a pretty big one, KC2H3O2. Well, I already know that K is just potassium. And if you look at the table from the previous slide, you'll see C2H3O2 is a polyatomic known as acetate. So this is potassium acetate. Now let's go ahead and do the reverse process. So here I took the formula and wrote down the name. We're going to go ahead and take the name and write down the formula. First up, iron 2 carbonate. Iron 2 is obviously iron with a +2 charge. Carbonate is, on the table, stated to be CO3, and this whole thing has a -2 charge. Now I can go ahead and crisscross these, but you see a 2+ and a 2- charge, and you can pretty much simplify those down to 1. So iron 2 carbonate is FeCO3. There's a 1 under both of these. Aluminum hydroxide. Aluminum is just aluminum with a +3 charge. Hydroxide is one of the few polyatomics that ends in "ide." Hydroxide is 1 hydrogen and 1 oxygen, and the entire thing has a -1 charge. So you're going to crisscross these, so the 3 goes under OH, the 1 goes under Al, so this is going to be AlOH3. However, if you notice, the purpose of putting this 3 under OH is to say that I have 3 OHs. But right now it's only saying that I have 3 hydrogens. It's not including the oxygen. So because you put a polyatomic ion, or put a subscript under a polyatomic ion, you have to enclose that polyatomic in a parentheses. So this is Al parentheses OH close parentheses 3. So now I know that I have 3 hydroxides. And lastly, sodium phosphate. Sodium is an ion with a +1 charge, and then phosphate is a polyatomic. It's PO4, and the entire thing has a -3 charge. Crisscross these, and you end up with Na3PO4. Okay? And that's going to do it for the polyatomics lesson. Make sure you are doing a bunch of practice problems and getting used to enclosing these polyatomics in a parentheses when you do add an additional subscript.